Good morning to everybody. My name is AJ Piskor. I am the Business Development Manager for Combustion and Advanced Controls at Lesman Instrument Company. I've been with Lesman Instrument Company for a little over 5 years. In a previous life, I had worked for Honeywell Maxon out of Muncie, Indiana. Spent about 10 years there as a field sales engineer, where I learned all about combustion and troubleshooting and starting up burners, and the majority of my combustion knowledge comes from my time there at Maxon. And I appreciate everybody taking time out of their busy schedules to join me this morning. And if you have any questions during the presentation, in the side panel there is a questions box. I will see those questions. And what I'll plan on doing is addressing those questions at the end. And I can also open up the phone lines for you guys to ask your questions to me directly. So why won't my burner light off? This is a common occurrence for anybody that has a oven, furnace, dryer, boiler application, where we need to advance through the different stages of a light-off sequence and get to a point so that we can be up and running and producing. So what I wanted to review with everybody is the typical light-off sequence and flame safeguard behavior, because we're dealing with combustion and trying to get combustion to occur. We just wanted to do a quick review of the combustion triangle and how it affects the reliability of the burner. Because we are using flame safeguards and different types of flame detection, I just wanted to also review those and how different issues with the flame detection could cause us some light-off issues. I also want to take a step back and look at everything else that's going on in the system outside of the burner, whether it's influence from the combustion chamber or any other electrical influence that could affect the light-off procedure and cause light-off failures. Just give you an idea of some other things to take a look at and consider. And for optimal, reliable, repeatable performance, I'll just do a quick review of the pilot turn-down test for you guys. Okay, here we go. So a typical light-off sequence goes through a couple of different steps, and not every flame safeguard and combustion system necessarily goes through exactly the same steps, but this is going to be the most common type of sequence that we'll find. And most of the literature and documents and equipment that I'm referring to relates mainly to a single burner type application where we're using a Honeywell 7800 series flame safeguard, but I wanted to make this a little bit more generic just because not every application is the same. Different flame safeguards may have different types of behaviors. Again, I just want to do kind of a general overview, mainly focusing on NFPA 86 applications, as well as the NFPA 85 boiler applications as well. They have a very similar light-off sequence and therefore similar issues with burner lighting off. So just to go through the steps real quick, we have initiate, standby, safe start check, the preignition purge sequence, pilot flame establishment, main flame establishment, and then run. At any one of these steps, you could encounter some kind of issues, and I'll go through and cite some examples and things to look for if you get stuck at each step in the light-off sequence. The diagram on the right is, you may have seen something similar to this. This is one from Honeywell. It shows the different stages of the light-off sequence and what terminals and LED lights should be on at that point in the light-off sequence. So it comes in handy, especially if you're not able to get all the way through the light-off sequence, just to make sure that you understand the behavior of the flame safeguard and know which terminals that either need to have power or should be absent of power during the light-off sequence. So just a review of the initiate step. it's the first step of the light-off sequence. As soon as you turn the power onto your flame safeguard, it's going to just go through a little bit of a boot up, just like turning on your computer every day. The main thing that the flame safeguard is looking for is that the voltage and the frequency of the incoming power is within tolerance. So a lot of times you'll have initiate startup issues if a piece of equipment is replaced where they may have specified the wrong model of flame safeguard and it's rated for a different voltage than the voltage that's coming in. Also, the initiate step, the flame safeguard is going through a little bit of a internal self-diagnostic check just to make sure that it's working properly. No fuses have been blown or any of the circuit boards are damaged or not functioning properly. With the Honeywell 7800 series, as well as some of the FireEye and the other flame safeguards, you have plug-in modules that you would insert to either indicate the type of flame detection or behavior of the flame safeguard, and not every single combination of flame amplifier and flame safeguard and configuration jumpers are valid. So it just goes through and makes sure that everything that you have in your little mini flame safeguard system is correct and applicable for your application. And within the initiate step, at least with the Honeywell 7800 series, if there is an abnormal voltage or frequency, it will put you in a hold. So it's not going to lock you out right away. It may recognize that, there might be some kind of an issue or adjustment that needs to be done. It'll usually time out after about 4 minutes and give you a lockout condition. So if that's the case, then it'll display, if you have the keyboard display, it'll display some type of message indicating what parameter is out of compliance. And again, if you are stuck in this initiate step, we'll just want to go through with a voltmeter, just verify that you've got the proper power for that model of flame safeguard, and also just the compatibility of the components. A very common issue that I see is that there's a model of Honeywell 7800 series flame safeguard where there's a configuration jumper underneath the dust cover underneath the display, where if you leave it intact, the flame safeguard tries to go through a recycle behavior upon a flame failure. But if you clip that jumper, it will go through and trigger a lockout condition. The recycle behavior is used in certain applications where it's applicable to the code, but it requires the use of a 0.8 second flame amp card. And what we see all the time is the customers replace the flame safeguard, they pull one off the shelf, they put it in, and they put their 3-second flame amp card back into the flame safeguard and then get a fault code 48 or 46 or something like that, where it says flame amp mismatch or some kind of similar message. And effectively what it just means is that you can't use the 3-second flame amp card if you have that configuration jumper still intact. So some people just forget that they have to clip that jumper if they're going to use that 3-second flame failure response time card. Again, with the Honeywell 7800, the keyboard display is not a requirement, but it's highly recommended. You can get a wealth of diagnostic information when you put one of these on. The one that I actually show here in my presentation is a slightly newer model that Honeywell released just a couple of months ago. Rather than the 2 lines of code, two lines on the display that indicate a fault code, this one has enriched text. You can see on the presentation, it has troubleshooting recommendations for you. So if you're already familiar with the existing keyboard display, this one is a really nice upgrade. So after initiate, we go into a standby. Essentially, it's just saying, hey, my flame safeguard checks out, but I haven't received a call for heat yet. So I'm just waiting until you tell me that it's time to go. So when it's in standby, it's just waiting for not only that the call for heat is coming in, but you also have your interlock string. And depending upon the model of 7800 series, or if it's a FireEye or a different flame safeguard, sometimes that terminal is one and the same, where your call for heat permissive goes through the same terminal as the interlock string. Other models have that on a separate terminal. So you just want to understand the behavior and the setup of your flame safeguard. In case you are stuck in standby, you need to know, hey, is it because I haven't given it a call for heat, or do I have an interlock that's open? So again, if you're stuck in the standby step, this doesn't seem to want to leave the standby. Again, we want to just verify that we've got voltage going through the interlocks and that we've got the call for heat. And this particular device, the expanded annunciator, really comes in handy when you're in run mode, where the burner shuts down and you don't know what interlock kicked you off. The expanded annunciator will let you know via first out that, hey, I lost flame because of my low gas pressure switch. This will also come in handy in standby. If you're not seeing your interlock string, an expanded annunciator is monitoring the voltage between each of your interlocks, and via the LED displays on the expanded annunciator and with communication back to the keyboard display, you can see exactly which interlock needs to be addressed or corrected. And again, the most common one that I see in applications is the manual reset device, right? Like an excess temperature limit interlock or a low or high gas pressure switch, which has the manual reset. Once you for a high temperature limit, once you go above the threshold, the temperature needs to go back below the threshold again, but it's not automatic reset. You have to go to the device and hit the reset button. So sometimes people forget to do that. Same with the gas pressure switches. So an annunciator will let you know exactly which interlock is still open, rather than you having to go through it, hunt it down on your own. Immediately after initiate and standby is the safe start check. So similar to the initiate, it just goes through and just makes sure that everything's working properly. It is also occurring during the pre-ignition sequence, because we're also at this point making sure that there's not flame that's already present, right? We haven't started the burner up yet. If the flame safeguard detects flame, it'll cause a lockout. So during the safe start check, not only is the flame safeguard just internally checking, making sure that everything's still working properly, but it's also making sure that flame is not currently present. I haven't ever come across an application where the system gets stuck in safe start check, but looking through the literature, it sounds like really the main thing is that if it's not completing the safe start check, there's some faulty component in your system, whether it's the flame safeguard itself or the amplifier card or the detection device. So now that we are going through the safe start check and have gotten the call for heat, we now go through the pre-ignition purge sequence. Now, again, not every flame safeguard has this behavior. Some versions of the 7800 series flame safeguard and FireEye and other flame safeguards do their pre-ignition purge prior to going through the initiate and safe start check. But for this example, I just wanted to showcase one of the enhanced controller versions where you need the flame safeguard to command the burner's actuator damper to go to high fire, and it has the internal purge card in there, because you can get stuck in this state. It will prevent you, for those types of flame safeguards, from getting to the pilot flame establishment period. So essentially this is a little bit of handshaking between the flame safeguard and the controllers in the field. We want to make sure that the actuators move up to a high fire position, maximum airflow condition, so that we can remove any potential gases from inside the chamber. Right? For those of you that work in NFPA 86 applications, ovens, furnaces, dryers, you know that NFPA 86 requires 4 volume changes of fresh air. So there's a formula that I have here on the slide that just lets you know how to calculate that pre-purge time. Honeywell has a number of different purge time cards. So after you go through your calculations and figure out what your chamber volume and your airflow rates are, and you plug it into the equation, you would have to round up to the next available purge card if you're using the 7800 series. So if you do your calculations and you find out that it's at 45 seconds, Honeywell makes a 30-second and a 60-second purge card, so you just have to jump up to the 60-second purge card. FireEye does this a little differently on some of their flame safeguards. They have configuration jumpers, which give you a little bit more flexibility in your purge timing. So you could, depending upon a model, set that for exactly 45 seconds. I think it's either in like 5 or 10-second intervals for their flame safeguards. And then some of the newer products like the Honeywell Slate system, you can put into this exact second what your pre-purge time is. Now, a key to the pre-purge ignition sequence is the purge conditions must be met for the entire duration, right? So if that high fire position switch breaks, or the airflow switch breaks, or your interlock string breaks before that pre-ignition timing has elapsed, it'll start back at the beginning of the sequence. So you'll have to go all the way back down again through the initiate, safe start check, and then redo your purge time all over again. There are some models and some configurations where it'll pause it and then resume it once it's met. But for the most part, they want to see that the entire purge time is done uninterrupted. So if you get stuck in the pre-ignition purge sequence, there's usually the main thing to look at is that handshake wiring between the flame safeguard and the actuator. So the flame safeguard is sending out a position command to the actuator, go to high fire. That usually takes anywhere from 15 to 30 seconds to achieve that, and then the actuator will send a feedback saying, I'm at high fire. At that point, then the flame safeguard will go through its purge countdown. And then after that's complete, the flame safeguard will command the system to go to a low fire condition. Again, some time will elapse, and then it'll see via switch contact back at the terminal, I see that I'm at a low fire condition. So at any point during that, if you lose communication, you're not getting the position feedback, the Honeywell will wait, and the FireEye will wait for a certain amount of time before faulting out. It'll say, okay, I haven't seen my high fire switch make after 4 or 5 minutes, and then it'll cause a fault or a lockout. So if you see that it's indefinitely waiting, you definitely want to check out and make sure that you're getting that handshaking properly. I also just wanted to add on here a tip for those of you that are into doing system design or selecting of components. It just adds a little bit of an additional safety factor, in my opinion, on your systems. Instead of using position switches that are internal to the actuator, you may want to consider using external position switches that are physically connected to the valves. If you think about operators adjusting linkages and And if you have somebody that's going through and doing some adjustment and then they leave a piece of the linkage loose or something becomes disconnected, you could get into a condition where during the light off sequence, the flame safeguard commands the actuator to go to high fire. Internally, that actuator is still moving and it makes that switch, but externally, with the linkage disconnected, you're not actually at that purge position. So, like I said, you may want to consider that. It provides you a little bit of an additional safety factor for that particular part of the light off sequence. Okay, so really the main where the rubber meets the road on lighting off a burner is during this pilot flame establishment period. This is the most critical step in the light off sequence, and this is where most of the time where I get calls or I've been to startups where I see the most failures occur, right? So there's a couple of things at play. One of them is the shot clock, if you will. You've got 10 or 15 seconds to prove that your pilot flame is on before you can advance to the main flame establishment period. So you're fighting a little bit of a battle, making sure that you're getting your gas flow to the burner. You've got your ignition source energizing, and your flame detection device is verifying presence of flame. That all has to happen in that short time period in order for you to advance. When I look at the issues that come up during a pilot flame establishment period, I usually lump them into two categories. So failure to establish a pilot flame and failure to detect a pilot flame. And I'll get into a little bit more detail on some of these. So of course, the failure to establish a pilot flame, that just means that, we're trying, but for whatever reason, combustion is not occurring. And we have to go back and think about our combustion triangle for a minute, right? We have oxygen, heat, and fuel all need to be present for combustion to occur. In a traditional industrial burner application, your oxygen is present in the airflow combustion air that you're bringing into the burner, and your fuel is going to be either natural gas or propane, butane, or any other number of fuels. The heat, in this case, if we're starting out on a cold start, it would be the ignition transformer and the spark that's generated. And really the key to the combustion triangle is that not only do we need all three of these elements, but we also need the proper ratio, the air-fuel ratio, or oxygen to fuel ratio to create that combustion. So when we look at the different burner designs, they're all very different with regards to how they do their pilots. Some burners have a completely separate pilot flame, which has its own supply of pilot air, and it produces a long pencil-like flame that reaches out into the zone where the main flame is occurring. Other pilots are just bringing a small amount of gas into the same nozzle that the main fuel is entering into the burner. So I think it's important to understand and learn about the type of pilot that the burner manufacturer designed into this burner, as well as the recommendations that they have for the adjustment and setup of those pilots. So I have here on the slideshow just an example of a Maxon burner. They call out the pilot capacity, and then they make a note to say that you have an adjustable orifice at the inlet of the pilot, and it should be about 4 to 8 inches of gas pressure at that point. So it's important to know exactly what kind of pilot that you're working with, how it interacts with the burner, and recommendations of the burner manufacturer, right? This will allow you to make the adjustments as long as they're within the spec from the burner manufacturer to give you the best chance for success. So in addition to the pilot gas and the air pressure, the spark igniter location is also very critical to where this is occurring, right? Because when you've got a pilot burner and you've got pilot gas and air being introduced into the burner, there's going to be a zone in which the ratio of the pilot gas and air is sustainable for combustion, right? So if you look at the area immediately after the pilot inlet, if there's not a lot of airflow at that point, it may be a little too rich to ignite at that point. And then if you go too far outside of that zone where you've got more dilution air coming in, the igniter might be a little too lean at that point. So it's very critical that we get the positioning of this spark igniter properly. And with good solid burner design, there usually is a little bit of flexibility with it. But I always like to go off of the literature and set that exactly to where it needs to be. I know that they have done numerous tests on the equipment to know where that spark should be located. And again, the literature will dictate and show you. Sometimes they have a nice little diagram like they show here on this slide. Other times you can see they call out different dimensions of the igniter. This particular style of igniter is it's got a locking nut mechanism, and that whole porcelain assembly slides out, and you can position that with a certain insertion depth, and you want to make sure that you are aware of the insertion depth and hitting those dimensions so that the spark is occurring at the right location. So I've mentioned a little bit about the pilot turn down test, right? So let's just assume right now that we've got our air and our gas and our igniter arranged and set up properly, but we just need to go through and do some fine tuning and adjustment. Because we have a limited time window for that pilot flame establishment period, there are some models of flame safeguard that allow you to do a pilot turn down test, which on the 7800 series, it may look like a run test switch that's located on top of the flame safeguard. And this buys you a little bit of time so that you don't have to go all the way back to the beginning of your light off sequence if you fail to light the pilot off right away, because you're trying to make your gas pressure adjustments. So what this looks like is that when you are going through the light off sequence, you've gotten up to the point where it's going through the pilot flame establishment period. As soon as you get into that pilot flame establishment period, you flip that switch, and then it will put on the display or through the LEDs, it'll just indicate that, okay, I'm holding you here for a certain period of time to allow you to get your gas adjustment. So you can take advantage of that time and make your pilot gas adjustment so that you can either, number one, visually see the flame, and then number two, make sure that that flame is being detected back at the scanner, or back at the flame safeguard by means of the flame strength indication. So typically on a burner like this one that's pictured, you've got the bronze adjustable orifice. You would turn that in to cut off the gas, or you turn it out to open up the gas. And because it's a fine needle adjustment, you can get that pilot to just at the point where you're satisfying that flame safeguard and maybe just a little bit stronger, just to be sure that you've got a reliable, repeatable flame. On the Maxon burners, like their oven packs, I was always told that you want to have a pilot that's about the size of a tennis ball. But again, different burner designs may have a different flame shape and a definition of a good flame. But really, the main thing is that I have customers and people that are trying to get the maximum and peg out that flame signal strength, and that's a good thing. But I also, I've seen it where sometimes they go a little too rich, and then they get some other issues down the road, like soot buildup on the igniter or the flame rod. So my advice is that it doesn't necessarily have to be the strongest flame signal. It just has to be repeatable. I want every single time that I go through a light off sequence, I want to adjust that pilot such that it's lighting off each and every time, and the flame safeguard is picking it up and recognizing it. All right, so these are some of the common sources that I see of failures to establish a pilot flame, so to physically light the flame. Again, when we look at the combustion triangle and look at the ratio of air to fuel, we need to make sure that we don't have too much combustion air going into the area where that pilot is occurring. Right? If you've got the version of the flame safeguard that's verifying your light off position, you should be okay, but some burners are constant air variable fuel. Other applications have changes in chamber pressure that could affect the amount of airflow that's going through the burner. But essentially, if you've got too much combustion air or pilot air going through the system, it's like blowing out a candle. You're never able to keep that on. And then the same argument could be made is that you just have too little pilot gas flow. Maybe your combustion air is fine where it's at, and the reason why it's blowing out is because you don't have enough pilot gas to the burner. So a little note that I wanted to share with the group is that these pilot lines, they're a fraction of the size of the main gas. So they're usually in very small, either quarter-inch or half-inch lines feeding the burners, depending upon the size of your main burner. I have seen these at times pick up some dirt or debris in the system, and because that adjustable orifice, there are a number of different styles of adjustable orifice. Some of them have a slot in the screw, and so that creates a very small opening, which is good if you have a very sensitive application where you need to fine-tune it. But if you think about dirt or debris getting into the line, it could plug that slot up fairly easily. So if you are seeing pilot pressure, but you're not seeing pilot flow, you may want to check your orifice and make sure that it's not plugged up and preventing pilot flow from getting to the burner. Another issue that I see a lot during the pilot flame establishment period, if I can't see flame, is the pilot gas takes too long to get there. There might be a number of feet and elbows between the pilot gas solenoids and the burner assembly. Really, the quick fix to this is just to put the pilot solenoid valves closer to the burner inlet, or add one if they're far away with the rest of the fuel train components. You can add a third pilot solenoid in there right at the burner just to reduce that amount of time that the pilot gas takes to get to the burner. Again, some back pressure. See this a lot of times on paper machine applications where the position of the hood and the dampers could increase back pressure on the chamber. So we just want to be mindful of that to make sure that those particular devices are at a safe position for light off. You may want to consider adding those damper positions or feedback into your permissive during the pre-ignition light off sequence to make sure that, hey, not only do I need to make sure that my combustion air and my combustion gas valves are at a low position, but I also need these other pieces of my equipment in the system to verify that we're at a low position as well. We could have ideal air and gas going to the pilot, but we just could have a bad spark igniter. Just like any electrical component, they could be prone to failure. Common spark igniter failures that I've seen is that there's been soot built up. This is common in applications where you either have a continuous pilot or you have a pilot that's set up too rich. Right at that zone of mixing where the spark is located, you could have a pocket of excess fuel, and that could cause buildup on the igniter. So you can either replace it or clean it off and put it back in. Another issue that I've seen is that if you've got a spark igniter that's got a little bit of a tip on there, I've seen it sometimes where because of either an improper installation or just a failed spark igniter. It's arcing at the base instead of the tip of that piece of the igniter. So that's something that obviously you want to just be mindful of, and I highly recommend that everybody has at least a spare spark igniter on hand, because that's one of the showstoppers, right? It's a very minimal cost for those components. Usually they're less than $50, and if you are having issues with it, there's no way of getting around it or faking it out. You need that igniter to run. So one is be mindful, and part of your preventive maintenance, I'd recommend keeping that flame, that spark igniter nice and clean. Seeing is believing, right? So I come across this all the time, where I'm doing a commissioning on a system where I'm looking through either the sight port in the chamber or back to the burner, where I can see the flame. You can see that nice blue glow, but for whatever reason, the flame safeguard is still not seeing it, right? So this is more of a failure of detecting it, but it just emphasizes the importance of having some kind of a visual element to the pilot flame. Not every single burner has a sight window looking back in, seeing it. So if that burner's not designed for it, we would certainly just recommend that there's some other port that's installed looking back into the flame. And typically the furnace and oven and boiler manufacturers understand this, and they either use a burner that has a window, or they install their own sight glass looking back in, right? Because if you are completely blind to, you don't have a visual on it, and you're not getting a flame signal back, it's really hard to quantify whether or not you've got a failure to establish a pilot flame or a failure to detect the pilot flame. Also, the different types of flame detection, some are more or less sensitive to pilot flames, and so you may need to make adjustments accordingly. I just got done with a startup where we switched from UV scanners to flame rods, and we needed to make some pilot adjustments because the flame rods weren't. We could see the flame, but the flame rods couldn't pick it up, so we had to make adjustments to our pilot gas pressure so that the flame rods could detect the flame. So just real quick, we're just going to go over flame detection, just because it's important to understand how these things could fail and what to look for. So the flame rods use the principle of flame ionization, right? There's positive and negative ions that are being exchanged in that flame that'll allow for current to pass through if it's present. Because we are creating a path, we need to make sure that the current goes to a proper ground, and that ground goes back to the control panel. And flame rods do have certain temperature limits to them, and not every single burner design or application is suitable for a flame rod. So you want to make sure that you review that with the burner manufacturer. So scanners are the other ones that we see. Typically, ultraviolet scanners are used for mainly natural gas, propane applications. We do see infrared applications for other types of fuels or other applications that prefer infrared. And ultimately, we're just getting a visual of that flame via the photo eye, and it's looking at that spectrum to verify the presence of flame. And again, just like spark igniters, some of the issues that we see with flame rods, that they just need to be positioned properly, right? If you have it inserted, not far enough or too far in, that portion of the flame rod that's exposed to the flame may not be getting the optimal current flow through the flame. So we just need to make sure that those are positioned properly, just like our spark igniters. Same with the scanners. right? They need to have a direct line of sight to the pilot flame zone. And again, typically the burner manufacturers know this, and when they design their burners and the igniter locations, they're focused in at the base of the flame, where not only are you picking up the pilot flame, but you're also picking up the main flame as well. Another issue that I see on startups is spark excitation, where I've got my ignition transformer energizing right at that point of the light off sequence. Once we go into pilot flame, I got my igniter turning on. If I have a UV scanner, there's a possibility that sometimes that UV scanner could pick up the spark, and that would be giving you a false positive. And depending upon your flame safeguard, sometimes that spark igniter just stays on, and then it'll go throughout the entire pilot flame establishment period thinking that flame is occurring, and then once it goes to the main flame establishment period, that spark igniter turns off. And if you see your flame signal go down right away, you know that either I had an issue with the spark excitation or something else was going on with the pilot gas, but I would lean towards spark excitation on that one. The behavior of some of the flame safeguards, some of them have an early spark termination feature, which is helpful because let's say I do have spark excitation, my spark igniter will shut down after maybe 5 seconds into my 10-second pilot trial for ignition. And if I lose flame right away, then I know that I never really had flame to begin with. It was just seeing the spark. A good burner design with the properly installed spark igniter, it wouldn't be detected. There's some kind of a shield or some method where it's sparking at an area of the pilot zone where it's not being detected by the UV scanner. Honeywell does make a half-wave ignition transformer, so if you do have a Honeywell flame safeguard and on occasion you get the spark excitation, you may want to consider the use of their half-wave ignition transformer. It will spark on the opposite side of the sine wave that the UV scanner is trying to detect flame. So they're out of phase with each other. So you could, in theory, have that spark right in front of the scanner, but it's not detecting the presence of the spark. So now we've got our flame present, but the flame safeguard is not detecting the presence of the flame. So some of these common sources of failure to detect is that flame rod is not properly grounded or improperly grounded. Again, thinking about the flame rod, it needs to have that path to ground. So if you got the flame and it's present, but you're not seeing the signal back at the flame safeguard, you may have a grounding issue. So we recommend that in those types of applications that you run an extra ground wire nearby to the burner housing, just to verify that you got a good solid ground to complete that current path. For a UV scanner, you could have a lens that gets dirty, right? It's trying to look through a sight tube and look at the flame, and if there's soot or dirt or debris that's building up on the lens, it'll start masking it to the point where it may fail to detect it. So we want to be mindful of that. The flame size is too small, right? So you can maybe see the flame visually, it's occurring, but maybe it's just too small for or too weak for the flame detector to detect it. So it just would mean that you're most of the way there. You just need to tweak your pilot gas or your airflow. Same goes where I've seen it where the flame is on with the igniter, but then as soon as the igniter turns off, the flame goes off. And again, that's just you're almost there. You just need to make a couple more tweaks to get that to latch in reliably. Flame has a weak UV signature, right? So again, I've seen it before where you've got a very, very pale blue flame. It may not be producing the strongest UV signature, and so you may need to make some adjustments just to bump that up. And then a very common one that I've seen is signal interference from the ignition transformer, like the spark excitation or the background noise, right? We've got a lot of other electrical components and things going on in these burner systems. You could have a condition where you might be getting some other signal interference that could be affecting your flame signal from being detected. So a couple of tips that I've come across that I would recommend to people having problems with the detection of pilot flame. Honeywell has what they call extended distance flame amplifiers. You may see as a little footnote saying for distances over 50 feet, use this model number. I have used that on applications where the distance is considerably less, and it's made a huge difference in the flame signal strength and the reliability and repeatability of that application. So you may want to look and see what model of flame amp card that you have, and see if there's a different version that is an extended distance version, and you can contact me and let me know. I can help you out with that as well. For the UV scanner applications, it's not a requirement, but good practice is to bring purge air into that sight pipe. If you suspect that soot is coming in from the burner or from the chamber, a little bit of purge air just to keep positive pressure inside of that sight pipe will help prevent dirt or debris from getting onto the scanner lens. And the other thing that I see commonly is customers are using older versions of the flame detection. So I see this all the time with the C7012 scanners. Now, Honeywell still makes them. They are available. If you like them and you have no issues with them, you're more than welcome to go through and use those. But if you start seeing some issues with the flame strength on those C7012s, I would recommend that you would consider using a C7061 if you have the ability to change those out and go with a different model number. I've seen much better flame signal strength on those types of scanners. And you would have to go through and replace the flame amp card if you're going to go with the C7061 or the C7012, but and that's a very easy change out to make. But from a pricing standpoint, at least the pricing that we list on our website, the C7012 scanners are more expensive than a 7061 plus a new flame amp card. So it is potentially going to not only give you a better signal strength, but also it would be a lower cost replacement item in the future. So now it's certainly not all of the issues that you could come across during a light off sequence, but I wanted to cover the main ones. But after you get to that pilot flame establishment period, now you're going into the main flame establishment period. And really, when I'm on a startup and I get through that pilot flame establishment period, I feel like I'm in the home stretch, right? I've verified that flame is occurring, that my flame safeguard is detecting the flame, but you could still get caught up in this main flame establishment period. Similar to the pilot gas, you need to have that right mixture of air and fuel of main flame in order for the burner to be satisfied. Typically on NFP86 applications, you'll have a single flame detector that has an interrupted pilot. So after the main flame establishment period occurs, that pilot drops out, and you'll see rather quickly once that pilot drops out if you have any issues with your main flame, because then you'll see that either flame signal drop out or drop off. So again, it's we verified that everything's working properly. It's now just making sure that everything's adjusted, air and gas are adjusted to the burner properly. I wanted to also highlight new to NFP86. They state that if you have a line burner that's 3 feet long, you need to have some kind of a flame detector installed on the opposite end, right? So a lot of times, right, the pilot gas that we're detecting is a small little tennis ball sized flame that's in the corner of these burners. But now when the main flame is being introduced, you need to make sure that the gas fills that manifold and flame occurs across the entire length of the burner assembly. So this could be another pain point, is that, hey, I've got a good pilot flame, but once I go to main flame, it doesn't seem to want to go all the way across and detect on the opposite side in time. When I see that sometimes that people are trying to ignite at too low of a light off position. So if you give it more gas, it tends to light off quicker. And within NFPA 86, they don't say that you have to light off at low fire. You just have to light off at a safe position based on the burner manufacturer's recommendation. And usually with these duct burners and these line burners, it's safe to light off at, let's say, 20, 30, 40% without causing any kind of issues. So it's possible that if you want reliable, repeatable performance, but you also don't want to take away from the thermal turn down of the burner, you may want to consider setting your light off position a little bit higher than low fire. And once the burner safely lights off and you verify flame has occurred across the length of the burner, you can then bring it back down to low fire again. And again, just like the failure to transition to pilot flame, the failure to transition to main flame occurs all the time if you don't have the right mixture of air and fuel. If that pilot is maybe strong and satisfied, but maybe that pilot flame isn't long enough or reaching over to that zone where the main flame is occurring, you could have that, which at that point you have to go back and readjust your pilot flame to make sure that you're advancing through and it's lighting off and kicking on that main flame. After I get through the main flame establishment period, it'll go through a run or modulate enable. So we've gotten to the point where the burner has lit off. So congratulations. We've actually gone through and have detected flame. We've gotten to the main flame. Pilot flame turns off. Now we're good to go. But I just wanted to let everybody know that, problems don't end there. And if you have problems while you're in run mode and staying up and running, I'll be doing another webinar on Thursday, March 26th, same time, called Why Does My Burner Keep Shutting Down? So similar to this, I'll go through common occurrences that'll happen with burner systems that will cause them to shut down, and go over examples and things to look for, and improvements that you could make to keep your burners up and running longer. So that concludes my presentation. Again, I appreciate everybody's time today. I am looking in here and I do not see any questions. I can open this up. If somebody in the menu on the side, you can either raise your hand or type in a question. I'll just leave a couple of moments here for anybody to ask any questions that you want me to address right now. If you had a more detailed question that you did not want me to review right now, my email address is right on the screen, ajp@lesman.com. I'd be happy to go through and address the question or give you some feedback on your inquiry. So I don't see any questions coming through. So this will end the presentation. Again, I appreciate everybody's time this morning. Again, please reach out to me. Let me know if you've got any questions. Actually, I do have a question from Will. All right, so I got a couple of questions here. So let me see if I can expand this. So Josh asks, direct fire makeup air unit that takes multiple pilot relight to sustain flame. So yeah, I didn't cover it, but there are applications where you have you don't have the pilot flame, you go directly for main flame. And on a direct fired makeup air unit, Josh, can you let me know, do you have a flame rod or a UV scanner on that application? Well, I'll just let you know that on a flame rod application, what I've seen on makeup air units is that they're typically, especially this time of year, it's cold and humidity could be high, and there could be condensation on the flame rod. And what I've seen is that sometimes you need a couple of attempts just to burn that condensation off. Actually, you know what? Let me just open this up. Okay, I've opened up the audio. Josh, were you still on the line? Josh.
Yes.
Oh, go ahead. There he is, Josh. Hi.
Hi. But basically, I think what you just covered that, which was I was concerned about atmospheric conditions on of course, the makeup air when it comes for conditioning of the incoming air. It is typically cooler or even higher moisture content. And what I've got is a fire eye system, flame rod, and it will just be sometimes frustrating because it's like I need it to burn off, but the fire eye wants to go into a lockout.
Yeah. Do you know what fire eye model that you have?
Not off the top of my head, no.
Okay. Yeah, I think that there are some that have I think I talked about it a little bit earlier, where there are behaviors that allow you to do instead of a lockout, it'll allow you to do a relight, but it shortens up your flame failure response time. They don't want you to have an extended flame failure response time, like a 3-second, and allow you to just relight after a failure. So they, at least with Honeywell, they require the 0.8-second flame failure response time card. So it makes it a little bit more sensitive, especially if that burner may flicker at times, where maybe you do drop below the flame threshold for a second or two, right? So the trade-off is that you can have the relight behavior to help you get up and running quicker, but the trade-off would be is now your system's going to be a lot more sensitive to potential flame failures during run mode.
Right, and then the other thing I've run across is
go ahead.
I was going to mention the other thing that I've kind of ran across is, especially if for whatever reason the system shut down, power outage, what have you, and then it's cold outside. When I do go into relight, then I start bumping into the time delay for the cold temperature inlet cutout and just standard restoration stuff.
Yeah. Okay. All right. Well, thanks for the feedback, Josh. Yeah. If you have any follow-up questions, feel free to email me and let me know.
Thank you.
Jason. So Jason Liu asked, anyway, there are earlier classes for why my burner is shutting off. So I haven't. So the webinar I'm planning on recording is scheduled for March. We have another topic that we typically are doing a topic once a month, and we have another vendor coming in. I was supposed to do it in February, but it got pushed back to March. But Jason, if there is a specific concern that you have about why your burner is shutting off, please reach out to me via my email, ajp@lesman.com, and I can look at addressing that sooner for you. Casey Madsen asked if you've ever had light-off issues with the Riello burner. I personally have not worked on the Riello burners. Mainly I'm working with the industrial burners like from Maxon and Eclipse. So I'm not familiar really with the Riellos at all. Casey, are you still on the line? Casey, I unmuted you there if you're free to talk. Otherwise, we can address this offline. Okay, I take that as offline. All right, Derek, thank you for the comment. I'm glad you found this presentation helpful. Will Vlasic is asking, I had a burner drop out after running. Now when I restart, I don't see the rest of the comment. Will, are you still on the line? I'll unmute you there. Will, are you there? Okay, I don't have Will. All right, Will, again, if you can hear me or if you have follow-up questions, please reach out to me via email. Cloyd asks, I may not have understood this point, but you said NFP86 requires detection of a flame at a distance, but that is set by the burner manufacturer. Oh, okay, so Cloyd, what I was referring to here is that for a line burner application where you've got a duct section where the burner is maybe 3 feet, 4 feet, 5 feet long. Hey, Dwayne, do you mind? I'm just going to mute you real quick. So if you have a burner that's 3 or 4 or 5 feet long, you know, you've got your pilot flame that's in one corner, and you need to prove flame propagation all the way across to the other side of the burner. That's where NFP86 says, hey, I need to have some method of flame detection on this opposite side, and specifically for line burners or pipe burners. The majority of the burners, like on a boiler, is going to be a nozzle mixed gun style burner where everything's occurring right there local, and you've got a pencil type flame that's occurring. That note in NFP86 is specifically just for a line burner, just to prove that you got flame propagation. The thing that they don't want to have happen is that you only have half of the burner array lit off and the other half just has uncombusted gas spewing into the chamber. So they just want to make sure that you're detecting it across the entire length. I hope that addresses it, Cloyd. Craig Allen asks, is there a difference in performance between 24-volt DC and 120-volt AC flame safety relay systems? There really is not. I just know that from experience, there's more options available with the 120-volt AC flame safeguards. Now, Honeywell's new Slate system is available in 24-volt DC, and it's got all of the behaviors and everything that you could ever want out of a flame safeguard. So if you are looking for a unique behaving 24-volt DC flame safeguard system, I would consider the Honeywell Slate. And again, you can email me and let me know if you've got any questions about that. Nick is adding a comment for direct fired application with safe start check failure on the RM7800 series. If the gas solenoid leaks, it won't relight because it's still sensing flame. Nick, thanks for the comment. Yeah, there is a post purge that occurs after you go through a light off sequence where if there's gas that's still present in the chamber, it gives it time to burn out, and that post purge is sometimes configurable. Usually it's around 10 seconds. But if you've got flame occurring because of a leaky valve, that safe start check will pick that up. It'll give you a failure saying, hey, I am detecting flame when I'm not supposed to see flame. And then at that point, you have to investigate and say, well, is the flame detector giving me a false reading for some reason where it's showing flame, but there's not flame present, or do I actually have flame occurring? So Nick, thank you for the comment. Okay, Casey, I see you didn't have a mic, so just email me back, or if you want to chat in the chat box, you can let me know. Derek, thank you for the comment. Okay, oh, Will, pilot is seen, main flame comes on, pilot turns off, main burner drops out. Okay, so that's similar to the, just that the, so if the main flame comes on, I guess I would question, are you really seeing main flame? Are you visually seeing that you've got main flame present, or is the flame safeguard still detecting the pilot flame? I guess that would be the main point. Okay, so Cloyd asks, so how could the requirement be anything but by the manufacturer? Okay, so Cloyd, on these line burners, they're modular in design. So you could have a line burner that's 6 inches long, 2 feet long, or 30 feet long. So the burner manufacturer, because different duct sections and configurations and capacities will require different size and shape of that burner. So you could have, and the burner manufacturer knows this, so they have all these different pieces, and typically when you go through and submit that order to the burner manufacturer, they want to make sure that on the end plate of that line burner where the pilot is installed, there's some other type of flame detection point opposite of that. I've had it before where we've either forgotten to incorporate it or we forgot to call it out on our burner drawing, and the manufacturer comes back and says, hey, listen, I see that you've got a line burner, it's over 3 feet long. You want to make sure that you put a flame detection port on that side opposite of the pilot. I hope that clarifies that for you. Okay, so Will, you said that the main flame does come on. Okay, so if the main flame comes on, and then after the pilot goes out, the main flame goes out. To me, that sounds like it would just be a question of having adequate main gas flow to the burner, right? So you see a little bit of a bigger flame, and then when the pilot goes out, then the main flame goes out. It's maybe in that time period where you've got the pilot and the main flame occurring, you've got adequate gas flow, but then when the pilot goes out, now you drop it off and it looks a little weak. That could possibly be what's going on there. Nick asks, on a line burner, can you light it in the middle to double the length allowable before adding flame detection? So yes, you can. I've got my code book here. I'm just going to look this up real quick. It doesn't say that you have to necessarily light it at the end. It's common because typically these line burners are installed in straight sections. But you can put a T section, and in that T section you could put a pilot end plate, and I have seen that before. So the NFPA code, I think I had it on my presentation, but I'll just read it again. A line burner, pipe burner, or radiant burner, flames propagating 3 feet or longer shall have at least one flame detector installed to sense burner flame at the end of the assembly, farthest from the source of ignition. So farthest from the source of ignition to me would mean that you could ignite it in the middle, but from that point in the middle, you now have to look and find which point now is furthest from the source of ignition. But that's a really great point, Nick, because let's say you have a 10-foot burner. If you have the pilot flame at the one extreme end, you now have to put the sensing element 10 feet away, whereas if you can arrange that pilot to be right in the middle, now it only needs to go 5 feet, which would, I would think, speed up the flame propagation process. So appreciate the comment. Okay, Josh, he said, is dual flame detection run in parallel to the flame safeguard, or does flame safety control have dual inputs on it? So that's a great question, Josh. So there are versions of the flame safeguard where they do have dual inputs on them. Not every flame safeguard has this. So what I've seen before is I've seen an external flame switch that's used and wired in series, or sorry, in parallel with the flame detection. So the main thing is that you want to, actually you have to have them in series, because you want to be able to make sure that if you're after the main flame establishment period and in your run mode, I think you have the choice to be made. You can either choose to detect both the pilot location and the side opposite, or you can switch it to where now I'm just looking at the side opposite, right? If you do both, detection at the same time, I think that those have to be in series with each other. I think that the spirit of the code says that I need to verify that flame has occurred opposite of the burner. And if you have those two flames, if you have those two wired in parallel, then you maybe haven't necessarily proved that you have flame propagation, because you could satisfy the flame safeguard with just the pilot flame, but you need to verify that you have it on the opposite end. So you either have to wire those two in series, or you have some kind of a relay that switches from the pilot detection to the side opposite to prove flame propagation. Hope that makes sense, Josh. Leah, thank you for the comment. Tom, thank you for the comment. And I think that covers everything. So again, I appreciate everybody's time this morning. Like I said, in the next few business days, this recording as well as the slides will be available on our website at lesman.com/train. And again, in 2 months, on March 26th, I'll do my follow-up presentation. Why did my burner shut down? And I hope to have you guys all on there. And of course, if you have any questions, please feel free to email me at ajp@lesman.com. Again, thank you all for your time this morning, and you guys have a great day.